Reliability is the probability of success. The probability that a system will be successful is the result of the probability that all its individual elements will be successful. Systems aren't necessarily made up of machine components. We have this issue of the reliability of components within a system actually embedded in this problem, which is essentially about travel. Regional Disaster Relief Services has decided to transfer half of its all-terrain vehicles to an overseas partner. Oh, okay, interesting. The partner is anxious to receive the ATVs in time to load a cargo plane leaving Singapore Changi Airport in 48 hours. All right. Global Freightways generously transports RDRS shipments on standby, meaning cargo is placed on board only if there is room after all paid cargo is loaded. Okay. Global Freightways flies nonstop from San Francisco to Singapore, and the probability that the ATV shipment is getting on board that flight is 70%. Ooh, now wait, before we go any further, I can draw that. What we're saying here is we want to get these all-terrain vehicles to Singapore. One option is to fly from San Francisco to Singapore directly, and essentially the reliability of that option is 70% because we have this one shot to get there. You say, yeah, okay. Now, as opposed to, there must be another option here. However, if the shipment is delivered to Los Angeles, okay, so a very different airport, Global Freightways can load it on a flight to Alaska, Anchorage, after which it can transfer to either of two flights to Singapore. The chance of flying on standby out of LAX is 90%, and 50% get on the first flight then to Singapore, 90% for the second. Which airport should the incident commander send the ATV shipment to? All right, this is one option. I better draw that other option because the other option is more complex. If you start at LAX, you could fly to Anchorage, which is probably a freight hub for them. Anyway, it's pretty high reliability that you would get there. 90%, certainly higher than this 70% I'm pointing to over here. Problem is it's more complicated than that because from Anchorage you still have to get to Singapore. The good news is that there's two flights. The less than good news is that there's only a 50-50 chance you'll get out on the first flight, but the second flight would work just as well, you know, you being the ATV shipment, and there's a 90% chance. Now, notice that there's a 10% chance that you won't get to Anchorage, and then there's a 10% chance maybe that you won't get to Singapore or something like that. It's a little tough to compare that to the direct flight, the 70%, but we can. We can by calculating the overall reliability of, think of the LAX itinerary as a system. Okay, essentially the direct flight from San Francisco to Singapore Changi Airport is also a system. It's just a really simple system. We don't have to do any calculations. Its overall reliability is exactly what they said, is 70%. Okay, we do have to do a little bit of scratch work for the LAX though, to come up with a number to compare to that 70%. Now, the LAX system consists of two phases, or two stages, right? First to Anchorage, then to Singapore. It also consists of a redundant set of elements. This business of there being two flights is an example of a redundant set. All right, in order to calculate the whole reliability of that entire system, we first calculate the reliability of the redundant set. Okay, we solve a small part of it first, and then we come up with the big answer. So we zoom in, and this would be true for any problem, not just for Global Freightways and Anchorage to Singapore. Okay, any problem, you're looking at a complex system that has redundant sets in it, first figure out what the reliability of the redundant sets are. Okay, it simplifies the problem. You say, well, yeah, okay, fine. How do I do that? How do I calculate the reliability of a redundant set? Well, first off, you could just think of it as logic, because sort of zooming in here, right? Let's see. From Anchorage to Singapore, there is a chance that we won't get there. Chance of not getting there. You say, well, okay, yeah, there is. What is that chance? Well, there is a 50% chance that you won't get on this flight, correct? You say, yeah, 50%. There is a 10% chance that you won't get on this flight, right? Or 1 minus 0.9. You say, yes. The only way that you're not actually, I mean, you being the shipment, the only way that you're not actually going to get from the freight hub in Anchorage to Singapore is if both those things happen, right? Okay, well, that means that the chance of them both happening, I didn't make the first flight, I didn't make the second flight, is the, now what did I just do? Joint probability. I multiplied them times each other. And you say, okay. So this little sub-exploration here, saying the answer is 5%. If you were just zooming in on that the little complicated business about getting from Anchorage to Singapore, there's a 5% chance that you won't be able to complete that leg. Why? Because remember joint probability. There's a 50% chance that you wouldn't make the first flight. There's a 10% chance that you wouldn't make the second flight. The only way to fail to make it to Singapore Changi Airport in that case would for both those things to have happened. That's the joint probability of those two events. Joint probability multiply the individual events probabilities times each other. Okay, so it's 5%. There's a 5% chance that you would not make it from Anchorage to Singapore. Okay, say, yeah, but wasn't I looking for the reliability of the Anchorage to Singapore leg? Wasn't I looking for the reliability of that redundant set? Isn't reliability the probability of success? And, you know, what you're obsessing on is failure? The answer is yes, but now you can state it, okay? Reliability of the Anchorage to Singapore redundant set, 1 minus 0.05. We worked pretty hard up here to find out the probability of not getting there. You take that out of 1. What's left is, well, that's nice. There's a 95% chance that given that you get to Anchorage, now notice we're still just up here looking at this portion of the system. Given that you get to Anchorage, there's a 95% chance that you'll then get to Singapore. And it's because of these two flights backing each other up. Now, those calculations here, they were actually, this is the formula down here for the reliability of a redundant set, any redundant set. A redundant set can have more than 2 elements. Our particular problem, it only had the 2 elements. And what did we do? We said the reliability of the first leg is 50% or 0.5. The reliability of the second leg is 90% or 0.9, right? So we said 1 minus 50% or 1 minus 0.5 is 0.5. 1 minus 0.9 is 0.1. That's what that is. We multiplied those together. That right there is the probability of not getting through. 1 minus all of that. And if there was a third one, we would have included it in here, and if there's a fourth one, and so on. Okay, now that is just how you calculate the reliability of a redundant set. We still haven't answered the question of where should they send the ATVs, because we still don't know yet, but we're a lot closer. What's the reliability of the whole LAX proposed itinerary? Now, the LAX itinerary consists of 2 phases. Getting to Anchorage and then getting from Anchorage to Singapore. We now know that if you get to Anchorage, there's a 95% chance of success that you'll actually get to Singapore. But there's only a 90% chance that you will get to Anchorage from LAX. So what's the overall reliability of this system? What is the chance that you will both get to Anchorage and then get to Singapore? It again is joint probability. There is, let's think about it, a 90% chance of getting from here to here, and a 95% chance of getting from here to here. So reliability is 0.9, that's that 90%, times 0.95, that's that 95%. I figured that out and got 0.855 or 85.5%. This is our assessment of the proposed LAX itinerary. We think that that will be 85.5% reliable. There is a 85-86% chance that you will actually get through to Singapore Changi Airport in 48 hours if you follow that itinerary. Oh, right, because, now wait a minute, there was sort of another formula, if you will, except it's very simple, that kicked in there. The reliability of a system is the joint probability of the reliability of its elements. That means that you wind up, if you have a series of stages and each one of them has a certain reliability, that means that you wind up multiplying them times each other to figure out the chance that you'll actually get all the way through to the end. Oh, all right, so the reliability of the LAX itinerary is the reliability of the first leg times the reliability of the second leg. Oh, all right, yeah, and that's what yielded 0.855. Now the question was, which airport should the incident manager send the ATV shipment to? How much better is the chance of on-time arrival in Singapore for the route that we select versus its alternative? We can finally answer. All right, these are our 2 candidates. You could do this or you could do this. Our answer, send to LAX, right? Why? Higher reliability. It has reliability of 85.5%, despite the fact that there is a connection or a changeover, versus only 70% for SFO, San Francisco. Normally, when we're traveling, we hate for there to be a bunch of connections because it does represent a diminishing probability of getting there on time because we have to multiply all the probabilities of the individual flights together. But in the case of this particular scenario, since they're flying standby, that actually winds up being a higher probability, a better chance than just the direct flight.